right, welcome. Today, we're pulling back the curtain on a classic digital heist, the SQL injection. We're going to break down how a hacker can steal a database's most valuable secrets, and get this, often without ever even breaking the lock. So, let's start with this question. How do you rob a vault without ever breaking the lock? I mean, it sounds impossible, doesn't it? But in the digital world, this kind of thing happens all the time. The secret isn't about brute force. It's about tricking the person who holds the keys. Okay, so every good heist story needs a target, right? A treasure chest. In our story, that treasure chest is the database. This is where all the good stuff is stored. We're talking customer data, financial records, logins, you name it. It is the digital equivalent of a massive bank vault. Now, you can't just walk up to this vault and ask for the treasure. Nope. You have to speak its language. And that language is SQL, which stands for Structured Query Language. Just think of it like an official request form. An application fills out this form to ask the database for something specific, and the database delivers. And this brings us to a really, really crucial point. The database itself is incredibly obedient. It's designed to do one thing, and do it perfectly. Answer the questions it's asked through SQL. It doesn't question your motives. If the request is in the right format, it just gives you the answer. It's powerful and secure, for sure, but it's also a very literal vault. So, if the vault is so secure and obedient, where's the weakness? Well, this is where our heist gets really clever. It's not a direct assault on the vault at all. It's an insight job, and it's all about exploiting a fatal flaw in the application, the go-between. And what's really interesting here is how this slide breaks down the roles. See, on one side, you've got the database. That's our secure vault that just follows orders. But on the other side, you've got the application. That's like the public-facing bank teller. It's the part of the system that has to interact with everyone, including users you can't trust. And because of that, it can be tricked. And this quote right here, this illustrates the single most important takeaway from this whole explainer. The source material is crystal clear about it. The weakness is not the database. The vulnerability will always lie in the application and how it handles the input it gets from users. So, how does the hacker actually trick the application? Well, they use what I like to call magic words. This is the heart of the injection. It's all about crafting a special piece of input that the application just doesn't expect. And because it doesn't know how to handle it properly, it leads to a really disastrous outcome. And that brings us to the formal definition. SQL injection is basically a vulnerability that lets an attacker sneak their own malicious commands into a totally legitimate SQL query the application is building. So instead of just looking up a username, the application gets tricked into running the hacker's commands too. Now, you might be thinking this requires some kind of super complex code, right? But a lot of the time, the very first test is shockingly simple. A hacker might just type a single quote character into a logging box or a search field. That's it. Just one little character to see how the application reacts. So how does this one simple character lead to a full-blown heist? Well, the real breakthrough for the hacker isn't just sending the quote. It's what comes back. See, a well-built application would just ignore it. But a vulnerable one, it panics. And in that panic, it starts revealing its secrets. And this is the jackpot. That single quote breaks the application's SQL query, causing the database to send back this really detailed error message. An error like this is like a giant, flashing neon sign to a hacker that something is very wrong. And for them, that means something is very, very right. Which, it kind of begs the question, why would a hacker want to cause an error? Isn't an error a failure? Well, not in this case. Not at all. For the hacker, seeing this error message is a massive success. It's like the teller just handed over the blueprints to the vault. And just from that one error message, look at the loot they've already gathered. They now know the database type is MySQL, they've confirmed an SQL injection vulnerability actually exists, and crucially, they now know exactly how to craft their next attacks, using queries built specifically for MySQL to view, edit, or maybe even delete entire tables of data. So how do we stop this heist from happening? Well, if the vulnerability is in the application, then the solution has to be securing the application. It's all about protecting the front door, not just trying to reinforce the vault. So let's just say it one more time because it's that important. This is an application problem. You secure the application, you stop the injection. It's all about teaching the teller not to be tricked by a customer's strange request. One really powerful tool for this is something called a web application firewall, or a WAF. Think of it like a security guard standing right between the public and the teller. It inspects every single request that comes in, and when it sees a known malicious pattern, like the kind used in SQL injection, it just stops the request cold. The attack never even gets a chance to reach the application. And that brings us to our final thought for today. We've seen how a vulnerable application can spill its secrets through a loud error message. But that's just one way in. Hackers have entire toolkits of magic words designed to get information in all kinds of different ways, sometimes by asking these subtle yes or no questions, or even just by seeing how long a database takes to respond. It really makes you wonder, if the application is the weak link, what other seemingly innocent inputs might be used to trick their way into our most sensitive data?